Hey grade 10s, welcome to a brand new section, a new beginning, a new opportunity for you to excel. We are easing into the foundations of trigonometry, and before we get into that, we're going to go over a quick concept, and that is the Theorem of Pythagoras. I know you've been doing it for 2 years already, so today's lesson is really short and easy, just to go over a couple of concepts. Then you need to do exercise 5.1 on page 102 of your textbook, which is pretty much an exploration activity. You're going to make statements and draw conclusions, and there's no real example to go over. This is just to get your brain thinking along the line of right-angled triangles. So without further ado, let's have a look at a right-angled triangle. This is the only type of triangle in which the theorem of Pythagoras will work. It's also the only type of triangle in which the trigonometry we're going to learn about this year will work. So right-angled triangles are important. First things first. We generally label triangles with capital letters, but another way of labeling the sides of these triangles would be to label them according to the vertex that is opposite that side. What do I mean? If you go and look at the side opposite that vertex of the triangle A, you can name that side currently, which is currently called BC, but it can also be called baby A or small case letter A, right? Likewise, if you look at the side opposite the vertex B, we can label that vertical line AC. Its other name can be baby B. And if we look at the side which is opposite the vertex C, we can label that either AB or baby C. Note that the side that is opposite the 90-degree angle is always called the hypotenuse, and the theorem of Pythagoras goes as follows. The hypotenuse squared, so AB squared, will be equal to the other two sides squared and added together. So AB squared is BC squared plus AC squared. If we were to write that same theorem in terms of these small letters, you would get the hypotenuse, C squared, is equal to A squared plus B squared. And whenever you write down this statement, you need to give the reason, Theorem of Pythagoras. Another way we work with the theorem of Pythagoras is often using x's, y's, and r's. And because y is usually a y-axis, and a y-axis is a vertical line, we tend to label the side of a triangle that is the vertical line a y. Then, because the x-axis is a horizontal line, we tend to label the horizontal side of a triangle as x. And of course, the last one is the hypotenuse, which is r, which looks similar to a radius of a circle. If it were to rotate round and round, listen to all those r's. That's why we sometimes call the hypotenuse r. So if we repeat the theorem of Pythagoras in this triangle, which has no labels at its vertices, but it has labels for its sides, we can say that the hypotenuse, r squared, is equal to the other two sides squared and added together, x squared plus y squared. That is the theorem of Pythagoras. Another way, if you were to be given the length of the hypotenuse and say the length of the vertical side, but you were asked to find x, we could change the subject of the formula so that x squared is r squared take away y squared. Likewise, if you are looking for y squared, it will be r squared take away x squared. Note that the hypotenuse in these subtraction sums always comes first. So r being the hypotenuse will be the biggest value of the three values of this triangle, of the three sides of this triangle. And so if you are looking for either the vertical or horizontal side of the triangle, you'll be subtracting from the hypotenuse. That r squared will never be at the end. You will never take r squared away from something else. Okay, another thing I'd like you to note is that the angles of the triangles can always be written in terms of each other. So if we were given this bottom left angle of this triangle and we called it theta, then we can remember that the three angles of a triangle added together give you 180 degrees, right? So this top right angle, that vertex up there in the top right corner of this slide, that angle can be written in terms of 90 degrees and theta. If we were to work out this angle here that has an arrow, we would take 90 degrees and the theta away from 180 degrees. Why? Because the angles of a triangle add up to 180 degrees. And if you were to simplify this, you would get 90 minus theta. So it's just something for you to mull over, to have at the back of your mind, that in any right angle triangle, the one angle will 100% be 90 degrees. The other angle could be called anything, theta, alpha, beta, x. And then that third angle of the triangle will always be 90 minus the angle that you've been given. In this case, it's 90 minus theta. So after this short little clip, I'd like you to go and do exercise 5.1, all of them on page 102, just for you to practice your knowledge on Theorem of Pythagoras and to make a few conclusions about the angles within right angle triangles. And then tomorrow we'll get into the nitty-gritty definitions of trigonometry. Okie dokes, enjoy and thank you.